Okay, I'm back. Here is puzzle 6. This one usually gives students a lot of trouble. Up until this point, what we've been doing is we've just been having something move across the screen in an increasing velocity, so we've had it accelerating. In this case, we want to actually slow something down, so we want it to decelerate. And what we need to understand before we get into this lesson is if we want it to go faster, the rate of acceleration is positive. If we go at a negative acceleration, we reverse the direction of whatever it is that we are acting with or acting on, so our sprite. And so in this case, what's going to happen, now that you've had some practice speeding things up, can you use the counter pattern to slow sprites down? So on this particular program, the car is going to run into the water. You need to use the counter pattern to slow it down. So we're going to use the Sprite.VelocityX block with a counter pattern to slow the car down by 0.25 as it moves across the screen. Discuss with your partner what do you think will happen when the car finally stops. And then we need to add code that makes the car slow down only if the velocity x is greater than 0. So we're going to go ahead and go through that challenge as well, and I'm going to show you and kind of explain what's going on and what's happening. So if we look here at the what's currently happening is it's set up in the program. The car is moving at a universal velocity, universal speed, going across the screen and goes right into the water. It's got a velocity of 10. It just comes across the screen and then it just goes through the water. And so what we want to do is we want to cause the car to slow down so that it doesn't actually go into the water. So we could just say, well, just set the velocity equal to 0, Mr. Twining, and then the car's not going to get into the water. Well, but then the car doesn't really move at all. We want the car to move across the screen, but then before it gets in the water, we want it to slow enough to stop. And so that's why we're decreasing the acceleration by this, or the velocity by this 0.25. So counter pattern, remember, is we are going to set something equal to itself, and then we're going to add something to that. So in this case, we're going to have the car.VelocityX. We need to get our math with the plus, because the counter pattern has us adding something to the car.VelocityX. So car.VelocityX equals car.VelocityX, and then we're going to add something to it. So in this case, since we want it to slow down, what we're adding to it is actually a negative number. We are decreasing the speed in order to slow it down. So we're going to, as it says, slow the car down by 0.25 as it moves across the screen. So we're going to have a negative 0.25. If you were really insightful, you could have put a negative thing in here instead of the plus, but I use the plus each time to try to help you understand that the counter pattern means you add something to the whatever it is that you're trying to increase, or in this case, we're decreasing. So if we click on this now, we see the car is going to slow down, but once it gets to 0, it's going to turn back around and go in the other direction. And so this is, as I was explaining, a negative acceleration is actually one that goes backwards. So what we did is we slowed the car down. We slowed down the speed until it got to 0. But because we were on the counter pattern, it was continually subtracting a quarter. So once it got to 0, it subtracted a quarter, and a negative speed means it goes in the other direction, or a negative velocity in this case. So the velocity, negative velocity, had it going back the other way. And since we were still adding negative 0.25, we were in the counter pattern, we were increasing that velocity as it came back the other way. So you can see that it was slowing down, and then as it went off the screen, it was speeding up again. Okay, so we start at 10, and then we go down to 0, and then we go to negative until we get back to the negative 10, and then negative 10.25, and then negative 10.5. as it goes through this counter pattern. And so the challenge here is to add code that makes the car slow down only if the velocity is greater than 0. Because once the velocity gets to 0, that means that the car is going to stop. So if we want the car to stay stopped once we get to 0, then we don't add, or in this case subtract, from the velocity anymore once it's at 0. So in order to do that, we need an if. Remember right here, if its velocity is greater than 0. And that's exactly what we're going to put in. So our comparison is going to be a greater than. So we say if the velocity x is greater, well actually we'll put a greater than in first. So greater than goes right here. And then we're going to put in a car.velocity x inside of my thing here. Just wanting to cooperate. Ugh. There we go. So, car.velocity x. So once again, we just read the sentence that tells us what comparison we need to put in there. Makes the car slow down only if its velocity x is greater than 0. So car.velocity x greater than 0. And that's the only time that we're going to cause it to slow down. So now, once we get to 0, it's not going to subtract anymore. The counter pattern is going to stop, and the car is going to stop. So now when we run this, our car slows, and now we got it to stop right before the water. Okay? So hopefully you kind of were able to understand this little puzzle, be able to get the challenge taken care of as well. We're going to continue to get even more complex as we go through the rest of this lesson. Oh, and hit finish. Yeah.